Whew. All right, hello, period 6. Sorry, but here we are. People who love you are all around you right now, and we are reviewing inequalities. Please check out this package I passed out on Thursday, and let's go. Okay, people in the room right now, what are we supposed to do? What are we, or maybe more to the point, what are we not supposed to do? What is a very, very tempting idea, however, if you do it, very bad things happen? Rick?
Subtract 1/2.
No, that's not a bad thing to do. That seems like a good thing to do. Or at least neutral. What's a bad thing to do? Maybe you don't know. La, yes.
Multiply both sides by x plus 1.
Yeah, multiplying both sides by x plus 1 is very, very tempting on the theory that we all hate fractions and the fewer fractions you can have in your life, the better. And won't that just make things simpler and we'll just have blah, 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 blah. Well, if this were an equation that we were solving, then that would be perfectly legitimate and that would even be like a good idea. However, multiplying by x plus 1 now would be bad. Why is that bad? Yeah.
I mean, I might be wrong, but if you multiply by like a negative number, don't you have to switch the sign?
Yeah, there's this whole thing that you learn in 7th grade or something, which that you have an inequality, and then you multiply both sides of this inequality by 3, then 3a is less than 3b. This hardly requires justification, that's just kind of like a duh. However, cool? Room say cool? Okay, however, if you multiply by negative 3, for mysterious reasons, you have to flip the inequality. Okay? Say okay.
Okay.
Hey, by the way, these reasons are actually just completely not mysterious at all. Watch and learn. Here's how I will explain. First, multiply both sides by 3. So that gives you 3a is less than 3b. Good? Now, subtract 3b from both sides, which is also a completely normal thing to do. So then over here you get 3a minus 3b is less than 0. And over here, now subtract 3a from both sides. Wait, did I do that right? No, sorry. Subtract 3a from both sides. So now that's minus 3a. And finally, if negative, what the heck am I doing? Oh yeah, if negative 3b is less than negative 3a, like if this one is less than that one, then it means that that one's bigger than that one. So just write it the other way. Negative 3a is greater than negative 3b. Okay, I have hereby explained and proved to you the weird, mysterious rule that says that when you multiply both sides of an inequality by a negative number, you have to flip the sign. Who's good? That's to erase this. Okay, was that necessary or unnecessary or who knows? Whatever.
Couldn't hurt.
Okay, since you have to, when you multiply both sides of an inequality by a positive number, keep the sign, and since when you multiply both sides by a negative number, flip the sign, I can't multiply both sides by x plus 1 because I just don't know whether x plus 1 is positive or negative. That's kind of the idea. Okay, the whole point of this problem is to find the set of all x values for which this problem is true. And not knowing that in advance, I can't tell you whether x plus 1 is positive or negative. Okay, so if I'm not allowed to do this simplifying move, what am I allowed to do? Now someone give me the right answer of what we're actually supposed to do, as you learned in week 3 of Precalc. Okay.
You combine the two terms on the flow.
You move everything over to one side and you smush them all together into one big giant rational expression. Go! I would put some music on, but then YouTube will block me. Instead, I'll just sing. Is this coming back a little bit?
Yes.
So you kind of you do a little bit of this, and then you do this. And now I just have a big, ugly expression on the left-hand side, and the only thing to do is to get a
common denominator.
to get a common denominator and to just grind out this whole big business. Yep. And I'm a math teacher, so I'm going to do this in the math teacher way, which is to write everything all out nice and clearly. Here you can realize that that's 2x plus 5. and what kinds of things do I have to do to get a common denominator? Well, this one is missing this denominator is missing a 2 and a 2x plus 5, yeah? So that's exactly what's needed. I think it's a good habit to just actually just write that in. And what's this missing? And this one's missing. So I mean, you can just skip that step, I guess, and do it in your head, but honestly it takes 5 seconds to just write it out, and it's just so much clearer that way. Alright, so now it's just algebra for a few minutes. Simplify everything all up into one big expression. Down to floor 2. Alright, nice exciting video that is basically silent, but all of this is kind of just algebra 1, just being careful, you know, negatives, fractions, distributive property, blah 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 blah. You eventually get something that simplifies kind of nicely. And then, of course, what else can I do? It's pretty much like one more thing I could do. Factor the top. It does factor nicely. And so we end up with x minus 2, x minus 6 over x plus 1, 2x plus 5. How are we doing?
Doing alright.
Okay, so now like the real thinking starts. Honestly, all of this was just kind of like a waste of time or something. Like this was just algebra practice. You know, kids can do this, but now real thinking is needed. How can I determine for this factored expression, this is called a rational expression, on the left, when it's positive and when it's not? Okay, wait, you're about to answer. Is everyone kind of more or less caught up? Whew. All right, there's even one more thing you could do, which is like a little bit optional, but you know, might as well. You can factor this 2 out here, which kind of seems like something you might want to do. So then you write this as x minus 2, x minus 6, and then the 2 comes out, and then x plus 1, x plus 5 halves. That's like somehow even simpler. or something. And then also, of course, the 2 is just like irrelevant, right? Multiply both sides by 2 or something, so just pop, you disappear. And really, this whole skill that we're building today is how do you, solve it from here? How do you determine when this expression is positive? Okay, every teacher has a little bit of a different way of doing this. Okay, and I'll tell you how I taught my classes to do this when I used to teach Precalc A and when I taught functions. Ready? This is what you do. This is, I'm going to call this the old way. This is a terrible video. This is the old way. Okay, the old way is great because it works. And it's also great because it makes complete sense. It's bad because it's just very annoying. Okay, so this is the old way. The old way says, all right, if I want to know when this is positive, well, it's a fraction, right? So I need to know when the numerator is positive and the denominator is positive, or when the numerator is negative and the denominator is negative. Okay, so duh, I basically need to know the sign of the numerator and I need to know the sign of the denominator. But of course the numerator is a product of two things and the denominator is also a product of two things. So what it boils down to is I need to know for each one of these factors, like exactly when it's positive and when it's negative, and that'll be enough to determine. Yeah? Okay, and so if I care about each one of these factors, then, x minus 2, for example, when is that positive? Well, it's positive when x is bigger than 2, and it's negative when x is less than 2. And this one is positive when x is bigger than 6, and it's negative when x is less than 6. And this one, it matters whether x is bigger or smaller than negative 1, etc., etc. Okay, so therefore there are 5 different kinds of numbers that I care about. The 5 different numbers that I care about are all the numbers from negative infinity to negative 5 halves, all the numbers from negative 5 halves to negative 1, all the numbers from negative 1 to 2, all the numbers from 2 to 6, and all the numbers from 6 to infinity. This is literally what I would make my students do at Precalc A. Okay, so then we make this giant chart, and we look for every one of these different kinds of numbers at each of the different factors. So, for example, take x plus 5 halves, bless you. Take x plus 1. Take x minus 2. And take x minus 6. And then we can, in a way that is very, I think, clear, answer the question. When is x plus 5 halves positive, and when is it negative? Well, the only way for it to be negative if x is less than negative 5 halves, right? So if x is like negative 3, for example, this is going to be negative. So this will be negative, but then subsequently it will be positive. Cool. Okay, how about x plus 1? Well, x plus 1 is usually positive unless x is a small number, and small in this case means less than negative 1. So this one is going to be negative until x hits negative 1, then subsequently positive. X minus 2 is going to be negative until we get to 2, and then for any number bigger than 2 it's going to be positive. And x minus 6 will be negative until we hit 6, then positive. Alright, so this is like total information. This is every possible thing I'd want to know. And now we just put it together, looking at the expression x minus 2, x minus 6 over x plus 1, x plus 5 halves. And there are these like 4 things that are being multiplied and divided by each other. Well, if all 4 of these factors are negative, then the answer will be positive. Okay, in other words, I've settled the issue for numbers between negative infinity and negative 5 halves. The answer is this thing will be positive on that interval. And then on the interval from negative 5 to negative 1, 3 of my factors are negative and 1 of them is positive, so it's going to be negative. And then here, positive, because 2 are positive and 2 are negative. And here, 3 are positive, 1's negative, so negative. And here, they're all positive, so positive. Okay, and so this is like not a bad method, honestly. And we're done. What is the solution to this inequality? It's going to be positive, it's going to be greater than or equal to 0 in those 3 intervals, right? So everything from negative infinity to negative 5 halves, and everything from negative 1 to 2, and everything from 6 to infinity. And then I need to get my parentheses and brackets right. If x is equal to negative 5/2, should that count as part of the solution set?
Yeah.
No, because you can't divide by 0.
Because here we get an undefined, so definitely not. What about if x is negative 1?
Nope.
No. What about if x is 2?
Yep.
Yes.
Yes, because now the numerator will be 0, and we want greater than or equal to 0, so, and what about if x is 6?
Yes.
Okay. Alright, if you can do all of that, then you are excellent at Precalc A, solving inequalities. Alright, next question, is this pretty much what Contreras taught you, ish, roughly speaking? Not exactly,
Just a
this,
number
but
line.
some variant of this, okay, in the same family. Alright, so I like this, it's great, it's clear, it's simple, it makes complete sense. Alright, however, it is kind of annoying. And by kind of annoying, I mean, it just takes forever, and you gotta draw this big giant chart, and it's just kind of like a drag. Okay, can we do better? We can do better. Let's call this inequality over here, let's call this like inequality 1. This is the inequality that we actually wanted to solve. Well, my claim is that for every one of the inequalities like this, there is a corresponding inequality that is a lot simpler. And the corresponding inequality is the one where you just move everything into the numerator and make it a polynomial. Okay, and so what I would like us to do from now on, when presented with that situation, just take everything into the numerator, so to speak. And this is another inequality. Let's call this inequality 2. Alright, and now, what do we notice about the relationship between inequality 1 and inequality 2?
They have similar solutions.
Yeah, and by similar, I hope you mean like almost exactly the same. Okay? If you were presented with inequality 2, and you didn't really know anything about polynomials, what would you do? You'd be like, oh, there are 4 things all being multiplied together, so I need to know when each of these 4 things is positive and when it's negative. What am I going to do? I'm going to make a chart. What chart am I going to make? Exactly the same chart, right? Except for the final row. We'll have a different label here, but it will be the same exact answers. In other words, this is the deep idea, which is kind of obvious, but maybe not. The answers to this inequality are exactly the answers to that inequality, give or take some finite number of like endpoints or whatever. Okay? And so, I don't really have to solve that inequality if I know how to solve this inequality. And I do know how to solve this inequality because what is this inequality? It's just a polynomial. And so what we're going to do now is we're going to lean on our knowledge of polynomials to be like, dude, this is just a polynomial. And I know what all polynomials look like in factored form. Answer, this is a quartic. 1 second. The roots are at negative 5/2, negative 1, so boom, 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 2, and 6. Also, those factors all appear with multiplicity 1, so we're going to have single roots at all those points. Also, the leading coefficient is 1, so the end behavior is up like this. Agree, agree? Okay, and so what's this polynomial going to look like? It's just going to look like this. That takes like 1 second to process, yeah? And, by the way, if you were doubting me last week, or maybe it was even this week, when I sort of taught you that, duh, this polynomial is going to look this way, and I kind of blew off a little bit, like the exact explanation for how we know that it's like positive, then negative, then positive, then negative. This chart is the justification for that, right? So actually, this is how, if you were teaching someone what a factored polynomial function looked like for the very first time, you could make this chart. This chart is proof that, in fact, this polynomial, because of its end behavior, will change sign at each one of its single roots. Okay, who's with me? All right, so what this means is, here's the new way. The new way of solving this inequality number 1 is as soon as you get to that point, you basically, in your mind, think of inequality 2, and then what I personally do is, I just make a number line, I just put negative 5/2, negative 1, 2, 6, and I think in my mind, this polynomial, and I just know this polynomial is, because of its end behavior, positive, then negative, then positive, then negative, then positive. And then I just write directly from this sign chart that it's everything from negative infinity to negative 5/2, union everything from negative 1 to 2, union everything from 6 to infinity, and then you get the numbers by, of course, going back to the original inequality, and the answer that we said was this. Okay, how you guys feeling about this new way? So we never have to make this chart ever again as long as you understand why we don't have to make it ever again. Okay, I'm gonna stop. Did you have a question?
It's more like if the multiplicity is like 2 for one of the factors, then you can't just like go like.
If the multiplicity is 2, then something is different. But okay, because so actually, good, I'm glad you brought that up. Here, for this particular example, they all had multiplicity 1. If one of these was a double root, then you would have to build that into your graph, right? So that's important. But we already now are experts on that fact of knowing that when there's a double root, it looks the way it looks. And there's one more thing I was going to say. Oh yeah, I mean, I guess it was already clear. But like, right, basically the motivation for this whole chart is like, since all we care about is whether the expression is positive or negative, it's like irrelevant whether the factor should happen to live in the denominator or the numerator, right? That's kind of the whole point. So we sort of convert these rational inequalities into polynomial inequalities, which we already know how to solve. Okay, does anyone else have any questions besides you? Is this a math question?
No.
Okay, say goodbye to period 9. Tried to keep this video nice and short. I mean, you are period 9. Whoa, that was one of those reference errors. Goodbye period 6. That was a 21-minute video. Pretty good.